Hello and welcome to this lecture on passing parameters to superclass constructors. Now, constructors provide us a very flexible ways to create an object. Now, there could be one constructor which is called default no argument constructors, or you might have overloaded constructors. Now, having more than one constructor is always a good practice because an object can be created quickly and an easy way. Constructor of a subclass can choose to execute different constructors from superclass. So at the end of this video, you should be able to understand constructors in an inheritance hierarchy, how to use them, is it possible to pass the values and so on. Use the super keyword to call the superclass constructor and describe the rules involved in invoking a superclass constructor. When a subclass inherits from a superclass, it gets everything from the superclass. It gets variables, it gets methods, it gets inner classes as well as constructors. But except that you can't really use that and you can't call the superclass constructor using a variable of subclass. Now there are some rules involved. A superclass constructor can be called by a subclass constructor only. Now a member method, however, in the subclass cannot call the superclass constructor. So constructor is done only during object creation only one time. Of course, one constructor can call another constructor and so on. So the entire object gets constructed with the combination effort of all the other constructors. Once an object is constructed, if you're trying to call a function, that cannot call superclass constructor. You can't do that at all. Now let's use a keyword called super. Call to the superclass constructor is done using the super keyword. In languages like C++ though, you make use of the name of the class itself to invoke the constructor. But in Java, you need to use the keyword super. Now super can be used in two ways. One is to invoke a superclass method as well, and another one is to invoke the superclass constructor. Now the super keyword is used as if it is a method name, and you supply all arguments that you require and call that inside a subclass constructor. Now here is an example. We have a class B extends A and we have a class B's constructor. Incidentally, this happens to be a no argument default constructor, but you can do that in any constructor. Now what do? You simply call super as if it is a function call. Now this looks for a function like body, like a constructor with no arguments. Now because you did not supply values, it looks for a default constructor in the superclass. Now, in the subclass constructor, if super is not called, then also it is implicitly called. Now, class B extends class A, and I am just having public B of like a constructor and no other code in that. There is an implicit call for the superclass default constructor. We don't have to do this, but it's a good practice and it helps readability to put super in case of if you want to call the constructors. Now, if you are calling a superclass constructor and it has to be the first statement in your subclass constructor. Here is an example. We have a class B extends A. We have public B of constructor definition, and I have here some method call do something. Now it will invoke something and come back, and then I am trying to call the superclass constructor. Now here is a syntax error. Compiler knows that this is improper. So it is going to provide an error message to you. So we need to be careful when you're doing this. The only thing you need to do is to switch this so that super call comes before do something. If a superclass has one or more overloaded constructor, no default or no argument constructor is provided by the compiler. Now remember, if you don't have a constructor, compiler can provide one. However, the moment you have some constructor, compiler will not give that. In such cases, if you don't have a default constructor but overloaded constructor, and if you are having a subclass, not even calling super will give you an error. And that's because it looks for constructor without any argument in the superclass A. Now this could be a problem at some point in time. So we need to know what kind of constructors that we are inheriting so that we can pass on appropriate values. So that's what we want to do. So we want to see how can we use that to supply values. Now here is another example, class B extending A, and we want to have some value in the subclass constructor, and we say super 12, 3.4. Now note that this is a compiler's responsibility to find out what kind of values we supplied, because it is a literal. So 12 qualifies as an int, whereas 3.4 qualifies as a double. And so this constructor call would look for a constructor which takes int and double in the superclass. Now that's what it's going to look for. Now if such a constructor does not exist in the superclass, again it's going to be a compiler error. Of course, if you have, the control just gets passed on to the superclass. So here is an example, product. So we have a class called product. You can think of that there will be some name, price and all those things involved. It's always a good practice to add a default no argument constructor, unless you have a reason not to have that. Imagine we also have an overloaded constructor that takes name and price. So whenever I want to create a product object, I can simply say new product, here is the name, here is the price. So at one single line, we have constructed a product object with values. Now when that values were supplied, they come and received in name and price. And what these two are going to be done, now they are just local variables. They have to be passed on to the member variables. So we'll say this.name equals to name and this.price equals to price. Now luckily for us, tools like Eclipse and NetBeans, they just create all these automatically by looking at the class structure. You just create the variables and ask Eclipse to do that. Eclipse will add this. But you need to know what is happening in this. So we supply some values, they come as local parameters and eventually be assigned to the members. Of course, before assigning, you can do some kind of validation, and probably if there is a validation errors, you throw some error messages and so on. Now that the class product is understood, let's create a class which inherits from this called television. Now television is a product, so we say class television extends product. Obviously, at this point in time, the television has a name as well as a price because of inheritance. It also has constructors and some other additional functions. But now, by default, compiler would have added a no argument constructor. What we want to do is, we want to have some television specific values maintained in this class, such as a screen size. Of course, a television can have many other features, but just for the example's sake, we are going to take one single variable called screen size. Now, we have a default constructor. If you use this constructor, this would invoke the superclass constructor without argument, and that's the reason I mentioned earlier that it's a good practice to have that. Now in the superclass, that is product, if you didn't have a default constructor, this would have resulted in a compiler error. Now that there is no error, let's look at another constructor. Now since television class has a screen size as a member variable, we would like to initialize that. And what we have to do? We have a constructor which takes screen size. But remember, product has provided two more variables to the television class. So if you take this particular constructor to initialize the television, you are only initializing the screen size, not the name, not the price. Now that's going to be a problem. Consider stack and heap. Now stack is where local variables get created and removed, and heap is where objects get allocated with some memory. Now let's create a variable called TV of television class, and that reserves some space in the stack. Now when we allocate memory for a television object, now in the heap there is memory allocated for name and price, which are coming from superclass, as well as the screen size, which is coming from the same class. Now the default values get initialized, that is null 0 0 and then 1 and then 0 for screen size. All those things happen automatically, and then there is a reference being created. Now after all these things are over, a constructor call takes place. Now the constructor that we used took one single parameter which we supplied as 29. Now this internally looks for a superclass default constructor, and that initializes name and price to null and 0 0. Now even if you don't have one, that would have provided by the superclass. Now the television class constructor, when it is resumed, it will supply the 29 to the screen size. Now if you see, the object got constructed completely, but name and price were never initialized. Now this is a big problem because we have a product, we don't know what is the name, what is the price. Now the other way to do is, now once you did this, you can now start calling tv.setName tv.setPrice and so on. But of course, we wanted to reduce the code. We wanted to put everything in the constructor. So how do we do this? Now, to initialize the members of the superclass, we have to receive the name and price also as parameters in the television constructor. Now, here is an example or a modified version of the same earlier constructor. We have a public television which takes name and price as also arguments, and then there is a screen size. Now that we have three parameters, the television member data can be initialized with these values. But how? We take this screen size and we assign something to that. We may not be able to assign the values directly since the members are private. So if you try to access the members and try to assign some values, you might get an error. For example, we have here super.name and super.price being assigned. Now you can't access this because name and price are private members of the product class. Even though they are inherited, they reserve some space, you cannot access. Now, how do we do this? How do we solve this problem? One of the way you can do is by probably accessing that superclass and then say, okay, let's make them as protected instead of private. If they are protected, then you can do this. That's not a problem. But what if the superclass is not yours? You are inheriting from somebody else's class and you can't go and change the source code, and you can't really do that at probably the production or the development time. You can't just go and change some source code. There has to be some reasoning for that. Now, the alternate to this would be make use of some setters. For example, we can have the same constructor. This time we'll say super.setName and super.setPrice. Of course, you don't have to use a super dot here because setName and setPrice are inherited members of the product. But this gives you more clarity. This is not a problem. And then of course we assign the screen size. But you're doing the same thing as what a superclass constructor would have done. Now this job we are duplicating now. But the whole idea of inheritance is code reusability. Where are we reusing? We are basically duplicating the code. Now this is where we would like to invoke a superclass constructor by supplying some parameters. So how do we do that? Now we want to make use of the superclass constructor by using the super keyword, and as if it is a function call and we receive name and price, we simply supply to that. But remember, call to the superclass constructor must be the first statement, and you can only have one super call in one single constructor. After the superclass constructor finishes its job, it will come back to this code here. That is when we take the screen size and assign to the screen size. Now, super is the way to call the constructor. You can treat that as a method call, but it looks for a string and a double constructor in this example. So any encapsulation logic, such as for example, validation logics, can also occur in the constructor call, which we just reuse now. Otherwise, we had to do that twice. We should check the name and price before we supply, but instead we are making use of the code already available in the superclass constructor. So if name is null or price is less than 0 or something, now probably the superclass constructor might create some problem. So here is the modified way, a modified constructor in action. So we create the TV variable just like in the previous case. We create an object, but this time the television constructor takes three different parameters. The first two correspond to the name and price, and the third one corresponds to the size of that. Now that we got it, so an object gets created. Now object gets created, a reference gets created, a reference is assigned to the TV. All these things are fine, but now the constructor is trying to initialize. The first thing in the constructor call we saw earlier that it calls super by supplying this name and price to the superclass constructor. And that initializes the name and price. Once the initialization is done, now it's going to take this 29, which is the screen size, and assigns to the screen size. So the object is now complete with proper values. Now this is how the whole constructor call from another constructor happens. So let's look at some exceptional scenarios. Now if a superclass constructor throws an exception, that means it is having some kind of validation problem. We don't want the object construction. So basically, throwing an exception from a constructor is an indication to the runtime saying that, hey, we don't want this object anymore. The object creation fails. So if the superclass constructors declares a checked exception, Now it becomes our responsibility in the subclass to protect it using a try catch, or you can say my subclass constructor further throws the checked exception. However, for an unchecked exception, this is not necessary. Let's quickly summarize what we have learned so far. Now, the default constructor of the superclass is implicitly called by the subclass constructor, and it happens to call the no argument constructor from the superclass. If that doesn't exist, you will have errors in your constructors. Now you can call any of the superclass constructors if you want using the super keyword as if it is a function call, and you can supply arguments to that to match to that. Now superclass constructor throws an exception means the superclass saying I don't want an object to be created. The same thing can be thrown away further from my constructor or subclass constructor, or you can handle it using a try catch.